Good evening. So let's talk about a problem pertaining to collision. And I will solve it for you. But before I do that, what characterizes this problem is the knowledge of maths. Okay, a lot of NEET students, face difficulty while doing, questions because of simple mathematical techniques. This problem is from the chapter of collision and dwells on somewhat elastic collision, right? Where your coefficient of restitution is between 0 to 1. If it's a 100% elastic collision, the coefficient of restitution is 1, which means the body goes down, collides with the earth, and comes back and attains the same height. But in the case of somewhat elastic collision, the body will not attain the same height. And in this numerical, what we will see is how do we apply mathematics to solve the problem. So wait for this numerical, and this will immediately follow this conversation. Thank you very much. All right, so this particular problem is pertaining to a collision which is somewhat elastic, which means the coefficient of restitution lies between 1 and 0. And the situation is that a ball, is dropped from some height h naught. It collides the earth, okay, here, and the collision happens, and the ball goes back. Since this is a somewhat elastic collision, the height which is attained back is less, okay? The height which is attained after the first collision is e square h naught. And you can work on the derivation of how we get it using law of conservation of energy or law of conservation of momentum, right? You can combine. There is a loss of energy because the height h1, is less than h naught. The next collision, again the ball comes down and the ball goes up. The ball attains another height which is h2. And this h2 this time is e squared times h1, the previous height, okay? So we can write this as e4 h naught. The emphasis of the question is not trying to tell what is collision and how do you get e square h naught. That's something which is different altogether. The point is how do you use mathematics and have some interesting inferences from this question. If you look into this problem, what you find is that the total collisions, are infinite. You can continue to have as many collisions as possible. So if I add the total heights, and I do some calculation, it will be the first height, from where it was dropped. Then it went up, okay, and it, this is h1, and then it came down, so this will be double. And then it again went up. So it will be E4 H naught and then E6 H naught, so on and so forth. So, you can be asked what is the total sum of heights which it attained, from the first bounce. So the first bounce looks like this. This is your first bounce. When you go up, you only touch this height, then you again come down and you attain this height. So what is being asked is to calculate the sum of this height, and this height, which means after the collision, whatever is a height attained, that has to be calculated, the sum of all those. Although this appears that it goes, it strikes the ground and then it goes up. What you have to calculate is this height, which is, after it collides and comes back. Those are the heights you have to calculate. And therefore, I am not, doing any calculation which involves this part of it. So you go down, strike, you come up, and you go down again. This part is not being included. What is being included is the first, which was dropped. Second, when you come up, and then you again come up. So all the coming ups are being included gradually, okay? And if you do a small calculation, which is you write this series, if you are, so this is the first time it was left from the ground, and this is the height it attained after the first collision. This is the height it attained after the second collision. This is the height it attained after the third collision. So in every collision, it is not able to attain as much height. So finally, it will be going like this, but you can't calculate. So this will continue till infinity. So this calculation continues till infinity, and therefore the total height which you are calculating, the sum of the initial height from where it was dropped, the first upward height, the second upward height, the third, comes out to be h naught 1 plus e square plus e4 plus e6 dash dash dash. This is infinity. Now, emphasis of the question was never on testing your knowledge of collision. The emphasis was, now how do you add all of these? So this is a GP, and the sum of GP when you have infinite series. So this is case of infinite collisions. The S infinity is given by the first term divided by 1 minus common ratio. If you look into the common ratio is the sum of succeeding term divided by the previous term. So if you pick up any two, you will, for example, you pick up the second and first, your ratio comes out to be e squared by 1. If you pick up third and second, your ratio comes out to be e4 by e square is equal to e square. So your common ratio, which is all across the series, is e square, and the first term is 1. So your answer is A, the first term, 1 divided by 1 minus e square. And obviously, since you're doing a numerical, this is h naught multiplied by 1 upon 1 minus e square. If you know the coefficient of restitution, for example, it is given to be 5 by 6, put the value here and get the answer. So you're able to calculate that an infinite bouncing ball, the number of bounces which are being considered are infinite. What you're mainly interested in, that after the first drop, which is h naught, how much high it rises in every collision. Calculate the individual heights using this formula, and then add them using the concept of S infinity. So this is more to do with some knowledge of geometric progression. You can expect similar numericals in class 12 when you do electrostatics, and you have to calculate sum of multiple forces which are arranged in a manner that you again get a geometrical progression. So geometrical progression has a key term called as common ratio, which is a ratio of the succeeding divided by the preceding. So any two you pick up, you will get an e square, and hence the common ratio is e square. For this particular case, you can have multiple cases. R can be anything, but R is between 1 and 0. So with that logic, you have to apply this. If R is greater than 1, then this formula changes to A divided by R minus 1. That's a minor change you have to do. But for the time being, if you have this concept clear in your mind, that how do you apply the common ratio in an infinite series, you will be able to solve similar numericals whenever you see a geometric progression coming in, right? So this was a combination of mathematical technique and knowledge of collision. The fact that it is e square h naught, you should understand it and be able to derive it. Remember, Earth with respect to the small ball is of infinite mass. So you should be able to have those approximations included and derive the expressions. Thank you very much.